Runner is one of the newest and most exciting parts of the official Marlowe suite tooling. Instead of connecting a node via Demeter or on your local environment, it lets you put your contracts to the test on Preprod testnet via the wallet extension. This goes way beyond the simulation inside Playground, as you receive the transaction hashes and get proof that your smart contracts work without issues in a production-like setting. The runner is in beta and will in the future likely offer mainnet deployment as well, which would open extremely interesting use cases of AI agents writing and deploying on Cardano autonomously. Something that with sufficient scaling and innovative fee management could revolutionize microfinance, prediction markets, or how DAOs share rewards among members. I am probably only touching the surface of possible use cases. Let us be clear, right now this has not been proven in real money, high throughput setting. But the promise is obvious and huge. It is possible to access Marlowe Runner directly from inside Playground in the Simulation tab. Instead of starting the simple step-by-step walkthrough with Start Simulation, or grabbing your code as a JSON download, click on Export to Marlowe Runner, which will connect to the network of your choice, with Preprod being the most likely choice. Once you have connected your wallet, you can see the contract from the perspective of the wallet and submit the contract to the chosen network for execution. All active contracts in your environment will be shown inside the Marlowe Runner, and contracts ID per contract shown with an icon to copy and investigate in a blockchain explorer. If you use various parties and want to see the changes in their respective wallets, I recommend using different Google profiles, each with the wallet extension installed and set to the same network. In our earlier example of the airdrop of native tokens, we have explored the limits of multi-party Marlowe contracts. It is probably not necessary to test more than 4 wallets with different profiles to see whether your logic is correct. But as shown here, for every user you need to paste the Preprod test network address before the contract is executed. As the script uses roles instead of addresses, this allows reuse and modularity of the script, even if the runner testing is made a little bit more involved because of it. The runner already recognizes correctly that we are dealing with a mint and token sending here, so the user interface responds to what are trying to achieve with the script. This is a major improvement compared to simulation inside Playground, where you don't have this and simply see that no errors occurred. With the wrong logic, your contracts may run without a glitch, but simply do not change ownership of certain tokens involved. With Runner, this will be clear. Uploading JSON files is a very convenient way in Runner to refine and reuse your scripts in and out of Playground or your code editor, sharing it on GitHub, and collaborating on code and re-importing it. The Runner will display JSON-style Marlowe and allows changes directly inside the Runner interface. So if you find errors, it is possible to change them on the fly and copy and paste the JSON for later use. Simply make sure you run a new transaction on the testnet. There is even a source graph option on the left-right of your code block, which allows investigation and high-level viewing of your smart contract flow.
So here I'm inside the Marlowe Runner, and I click on Upload JSON, and I see my Marlowe GitHub folder where I can select the contract that I want to investigate and deploy. This is the airdrop, and the source graph looks like this. You can toggle back and forth between code and source graph. Upload the actors PAM contract. Okay, so this is not the right format. Is stablecoin by USD. Let's submit the contract, and then it will require us to obtain these Preprod testnet addresses to have 2 more counterparties except our own wallet here, which is the role of the distributing parties. So these 2 parties will receive a role token, specific token that we will mint inside the airdrop transaction. So as I said earlier, I prefer to use different Google browser profiles. So this keeps all the transactions apart from one another. and you can see the tokens that end up for each particular user. You can also request testnet tokens for each of these wallets and then do financial transactions and see how the cash flows between these accounts. So this is a good way to simulate, in my opinion. And then you simply take these additional users. It recognizes this as a valid prod address. And this one as well. Paste it here.